Good day, academians. Of course, we're continuing from the parabola. Now we're doing a revision for the hyperbola. Now, the parabola and hyperbola are different, but for sure now you've noticed that pattern where that each function has its own standard form, right? Now, the standard form for this one would be y is equal to a over x plus minus p plus minus q. Why are you using plus minus? Because it's not always plus and it's not always minus. It changes around, right? But now, if you remember the thing I said about x's being complicated, right? It still applies here, right? But now, here we'll introduce a new word, if you haven't heard it before, a new word that we call asymptotes, right? Now, I call these ones the don't touchy, right? Because if you have asymptote on your graph must not touch the asymptote. It can come close to the asymptote, but it cannot touch it. Let's say, for example, you have the asymptote over here, right? And this is u. You can only come close to the asymptote like this, but you cannot touch it, right? Right? You cannot touch it. That's what I mean when I say don't touch it. You don't touch it. So same as the graph, it will come close to the asymptote, but it will not touch it. Now, right? If you remember, P and Q represented the vertical shift and the horizontal shift, and it also represented the coordinates of the turning point of a parabola. But here, they represent the vertical and horizontal asymptote. Now we can see that P is the vertical, right? It is the vertical, right? I think it's the vertical asymptote. It is the vertical asymptote, right? And then the same thing for Q is the horizontal asymptote, right? Now, what you must pay careful attention to is that, as we said that Q shifts the graph up or down, and P shifts the graph left or right. That is still true, but now the problem is that when it shifts the graph up or down, we now say that if it shifts the graph maybe 3 units to the right, we have to draw the dotted line, and then our graph cannot touch this line over here, right? It cannot touch that line over there. It does shift the graph to the 3 units, 3 units to the right, but the graph will not touch that line, right? But I know most of the stuff doesn't make sense when you're looking at it like that. So let's try and look at A. Then I will continue to draw something. Then I'll show you what I mean about the P and Q, right? Because it's just revision at the end of the day, guys, right? Now, you have two things like this, right? Now, when A is greater than 0, what did we say? When it's positive, right? Or when A is lesser than 0, which is negative, what do we do, right? Now, which A? Let's A. When A is positive, we do it on the third and first quadrant, right? If A is negative, we do it on the second and fourth quadrant. That's how you draw. If you remember, I said to you on the parabola, when A is lesser than 0, it is sad. When A is greater than 0, it is happy, right? So now, how do we look at it in terms of that notion? We can draw a line over here and see, okay, this line is increasing, right? What is increasing? Positive, right? So now we know that our A is positive, right? So we should draw a line between this one and we should draw the graphs between this one and this one, right? Now the same thing will happen over here when we say A is lesser than 0, meaning is decreasing, negative, right? So we draw a line over here. What is that line doing? If we read from left to right, right, it is decreasing, right? So now we know that we should draw on this quadrant and this quadrant. I think that's a better way of looking at it, but you can cram it your own way. Like I said, it is just revision, right? Now, here, the the one thing that you must know is that the domain and the range are also the same as the others, right? But now here, the domain, you just say the x is an element of real numbers, but x must not be the asymptote, the vertical asymptote, right? Now the same thing must happen here, that y is an element of real numbers, but y must not be q. Why am I saying that? I'm saying it can be anything, because as you see, the graphs continue, the graphs continue to infinite levels, and the one thing that we can restrict them with is the asymptote. And I say to you, the asymptotes are what? Don't touch it. They do not touch the graph, and the graph does not touch them, right? Now the same thing, if I have, let's say for example, if I have 2x minus 3 plus q, not q, let's say plus 2, for example, let's say plus 2, let's say plus 2 plus 2. Why is this thing not pressing? Okay, it's pressing, right? Let's say this is our graph. Now where is our asymptote, right? This is p, but remember what I said to you with p. I said if it's negative, then you write it as positive, right? You say p is equal to 3, so meaning your vertical asymptote will be here, right? So you draw that vertical line over there, and you say that here, when they say they want the equation of the asymptote, you just say x is equals to 3, right? Because of course over there the x value is equal to what? It is equal to 3. But now this graph has been shifted how many units? 3 units way to the right, because remember I said x's are complicated, so when you see a negative, it is to the right. When you see a positive, it is to the left, right? Now they also shift the graph how many units? 2 units way up, because that is the q, right? That is the vertical shift. So now we are going to go 2 units up over here, 1 2, all right? And let's say this maybe here is 2, right? Now we have shifted the graph 2 units up. Now where must we draw our graph? Which quadrant? Remember, here's a, right? A is what? A is positive, so we must draw a line that is increasing, right? So we must do it like this, do it like this. As you see here, my graph gets close to the asymptote, but it does not touch the asymptote. Also over here, the graph must get close to the asymptote, but it does not touch the asymptote. So that's what I mean. But other than that, good people, there's really nothing more or nothing less to the hyperbola. The one thing that you must know is that it has axis of symmetry. Now the axis of symmetry are lines that divide the graph into 2. So you'd have a line that does this, straight line graphs, right? And this. Now what you must know is that the one that is decreasing, right? We have, let's just say we have two axis of symmetry. We have 2 axis of symmetry, which are lines that divide the graph into 2. Right, now we have one, the gradient is positive, right? And then we have number 2 where the gradient is negative. But what you must take note is that their gradient is always 1, right? And for this one, because it's negative, its gradient must be negative 1. Then their equations are always y is equals to x plus c if it's positive, y is equals to negative x plus c, right? Because it's negative 1 over there at the front, and there is positive 1. These are the gradients, right? So the gradients remain constant always, guys. If they say which one, draw the one, find the equation of the axis of symmetry with a negative gradient, you are going to use this one. If they say find the equation of the axis of symmetry with a positive gradient, you're going to use this one. But of course, this is just revision, axis of symmetry, whatever. We're just trying to get the gist of what we are doing. And what we must also know is that the two asymptotes meet at what? At P and Q. Remember, at that point, we said in the parabola, right, P and Q, whether turning point. But now here, it is the intersection between the vertical and horizontal asymptote. Now, guys, I want you to rewatch this as many times as you can, because there's really nothing more, nothing less. Because here, it's just simply cramming. The part here, I don't want to lie, this here, you just cram because it doesn't change, right? For the other ones, it is going to get really, really interesting, as a lot of things are going to change. But for now, I want us to stick to what we know, right? Which is a revision of grade 10 and grade 11, and that's just it. When some things pop up, I'll show you. Even this one, I'm not going to do a paper for this thing, right? I'm not going to do a paper for this thing because it's really not that hard. But of course, when we do functions as a whole, past papers, I have to include it a lot because there's mixes where you have now, you expect something like this, maybe a parabola, maybe a straight line, or maybe, for example, you have a hyperbola and maybe a parabola and maybe a straight line, right? So it does happen, right? It does happen, but I'll teach you that way when the time comes. Of course, for now, we're just doing what? We're just doing revision. So revision is just reminding you of the stuff that you did in the lower grade, so that you cannot get lost when you start speaking about the domain and restricting it like this, and speaking about the range and restricting it like this. Of course, when in an exam, you would put the relevant p value and the relevant q values, right? That's what I mean, right? So don't forget those properties where the x is complicated and all those things. They are very important, right? So I'm teaching you the things that I know that they are very prone to show up. Axis of symmetry, the two axes of symmetries, you must always know they are all straight lines, because as you see, they are all straight lines. That's what you must know. They're all straight lines, so you must know those axes of symmetries. And other than that, guys, there's really nothing to a hyperbola. I'm just yapping right now, so I'll see you on the next one.